12s. Right, guys, really quickly, let's do some review of some Hess cycle questions. So this particular homework that I've set you guys to do is focusing specifically on using cycles. So these are cycles which are drawn for you, and it's applying what they provide you with to be able to solve the questions. So let's share screen. Let's crack straight on. I have no idea. I'm not going to even bother with the chat window because I don't have time to do it in this particular one. So I'm not going to turn my camera off or anything. Right. So this is energetics lesson 5. I'm just going to put L5 cycle review. And then I'm going to insert printout. Let's go for documents, year 12s, energetics, using cycles. Right, as I said, this is specifically about being able to use a cycle that they provided you with the data in order to solve for the heat energy change of a reaction which is unknown. So, okay, let's be quick. I'm going to switch to pencil and I'm going to do it in red. That'll do. I might make it even, yeah, okay, because I can zoom in. Okay, so first question, they've given us a half complete cycle, and what we've got to do now is just figure out which way the arrows are going, what the data they provided with, etc. So if we look at the data, look at question number 1, section number, data number 1, and it's given us the combustion of hexguanine. So if we find hexguanine in our cycle, which is over there it is. So now I can say if we burn that, I'm going to form CO2 and water. We realize the arrows are coming down. I always say that combustion arrows come down and formations go up, but this actually isn't entirely true depending if they give you a cycle. In this case, we know that in that bit of data, this data states that we're going to take C6H12 and I'm going to add oxygen to it in excess, not going to bother balancing the equation in this case, and I'm going to form CO2 and water. So the arrow is going towards the CO2 and water, which is down here, hence why my arrow is coming down in this situation. Now, in this cycle, they've been nice because there is one of these in it, and we know that this bit of data is the combustion of 1 mole of hexguanine. So I can apply that 4003 to that number. Next, they've also given us the combustion of hydrogen, and there's that. I'm going to move that onto the other side, so minus 4003. I can also burn hydrogen, and what I'm going to create is I'm going to create water. So I can now add that bit of data. Now, the great thing is there's a 1 in there as well, so I don't need to multiply that by a number either, minus 286. If there were big numbers in this scenario, if there was a 2 in here, I would have to multiply that by 2 because the data is for burning 1 of them. Yeah, so it's just nice for me to mention this because it's not there. I don't need to. The next thing is they've also given us the data for burning 1 mole of hexane. So we're going to burn that as well. And again, there's only 1 in the equation up the top, so I only need to apply 4163. We realize the most important arrows in a Hess cycle. That way equals that way. Start at the same point and end at the same point. Yeah, so the 2 most important arrows are there. So this is the original. I'm going to do them in different colors. Here's the original. This is what I'm looking for. Yeah, and here's the new root. Yeah, there's the new root. So now we need to build our equation. So this arrow here is going with me. So I'm going to say delta H question mark equals plus, it's with me. That's plus means with me. Yeah, brackets minus 4003, close brackets. This one is also with me. So I'm going to add that one as well. So plus brackets minus 286, close brackets. This one over here is against me. So I'm going to minus it. So minus brackets minus 4163. I type that into my calculator exactly as I have written it, plus brackets minus 4003. I know you mathematicians in the room sit there going, I just like to flip the signs in my head. When these get more complicated, yeah, I'd recommend for you not to do it because when they get more complicated, you end up making a mess of it. Yeah, minus. So I've done plus brackets minus 4003, close brackets plus brackets minus 286, close brackets minus 4163, close brackets, and my final answer is minus 126 kilojoules per mole. I am done. Tick it if you got it, folks. Let's move on to number 2. Right, okay, this case, they've given us some really bizarre reactions. They're seeing if you can apply the concept. They've given you a cycle. They have given you data. Find these equations in the cycle. Where is it? So in this particular one, I'm going to color code all of these. So this one here, I've got HCl going to H plus aqueous and Cl minus H. Where is it? There's HCl. Start there. Going to H plus, right, there it is. I found that one. That's the green arrow. Amazing. Let's apply my number. So I've got one HCl here. I've got one HCl here. That's minus 75. I'm going to shrink my pen. Try and be quick as I can. Minus 75. Next, where is this bit of data? H atom gas plus Cl atom gas goes to HCl. Where are the atoms? Where are the atoms? There are the atoms. There's the arrow going to HCl. Apply my number. Green. That becomes, and I've only got 1, 1, and 1, and that's exactly in the equation. So I apply it. Minus 4, 3, 2. Next. Right. Minus. Next. Okay. I need, I've done green. I've gone for pink. So I need this one. So where's H gas? There's the H gases going to H plus and Cl minus gas. There's that one. So there's my pink arrow. Right. Apply my number. The numbers all add up in the equations. This is good. So I can now go green and go plus 963. Very endothermic. Wow. Very, very endothermic. Right, and what we're after is this way is the original, which is what I'm after. And I'm now going to go this way. Right, let's create the equation. Right, so the pink, so delta HR equals, so I'm going in this direction all the way through. The pink arrow is against me. Minus brackets, plus 963, close brackets. This arrow is with me. Plus brackets, minus 432, close brackets. This arrow is with me. Plus brackets, minus 75. I type that into my calculator exactly as I have written it. Don't flip anything in your head. You will make a mistake. 432 brackets plus brackets minus 75, close brackets. And I get an answer of minus 1470 kilojoules per mole. And I'm done. Seems very reasonable. Yeah, we're hydrating them. That makes sense. It's an exothermic. All hydrations going from gas to aqueous. The ions are forming bonds with water. It's going to be very exothermic. Seems very reasonable to me. Right. Let's go to the next one. Next one, please. Yeah, seems all very reasonable. Next. Right. Okay, this one's nice and easy. Multiple choice. This way equals this way. I'm going to change my color. This way equals this way. So I'm going to have plus delta H2, and then I'm going to have minus delta H3, and so delta H1 at the top equals those two. So delta H1, these are all the same, so it could be either one from that perspective. Then we're going to say, right, there's delta H2. Oh, hang on a sec. Yeah, because there is one there and one there and one there and one there. So there's a big number 1 in front of here. So any 2s, these 2s are now out the window. Yeah, nope, they're all wrong because there's only 1 in the equation. So it's either A or B, and it's going to be plus B and then minus 3. Plus 2 and then minus 3. It's A. I'm done. Let's move on. Hardest question of all. You've got to finish the cycle. Okay. This is a bit more challenging. They've provided you with 2 equations at the bottom, yeah, for H3 and H2. And then what they've done is they've given you this cycle and they're expecting you to figure out what's going on. And you can see what they've done. They've done a clever trick. They've done the HCl. There's the HCl in these equations. Who did I start off with? I started off with him. So that there is delta H3. That makes sense. The next one is, here's this guy. This is where I need to color code everything again. Yeah, there's this guy and this guy. So there's that one. Yeah, let's highlight them with their colors. And then I've got this guy, and I've got this guy, and he's in this one, which means I need an arrow. So we're adding HCl. That's awesome. So we're going to add 2 HCls. It's nice that they add up as well, 2 HCls there. You don't ever need to put those in a Hess cycle, by the way. It's really stupid. But what you realize is you get the same products. So the first mark is going to be for putting these products down here. MgCl2 plus H2O plus CO2, and then state symbols. That's aqueous, that's liquid, and that is gas. I like it. So there's 1 mark. That's all we had to do. The arrow the marks there come from this arrow being highlighted that and everyone on the state symbols being correct. Now, they then say, use the values provided. Okay, hang on a sec. So they've then given us these values. There are the values. So we can apply the numbers. Let's apply this data. So the green one, delta H2, which we've realized is this guy, yeah? And I'll write that on, which is delta H2. Let's apply the number, and there's the data. It's all about just applying data. So that now becomes minus 126. No multiplier because there's a big 1 in that equation that's invisible. And of course, any enthalpy of reaction, it's 1 mole in the equation, which is there. So we don't need to multiply it. The next thing is, we also realize that this one then, of course, is, I'm going to orange it. So there's this value here, goes with these guys. So let's apply that number. That becomes minus 231. And the most important arrow in a Hess cycle, this way, equals this way. So let's find our final equation. So then we're going to say, so delta H question mark, which is him, delta H question mark equals, like this guy is with me. I'm going to increase my pen size. Yeah, delta H question mark equals this. So he's with me plus brackets minus 126. And then this guy here is against me. Minus brackets minus 231. Close brackets. Run it through your calculator exactly as you've written it. Plus brackets minus 126. Close brackets minus 231. Close brackets equals plus 103, and there's my answer. Kilojoules per mole. Winner. Next. Oh, that's okay. I added this one. Guys, that brings me to the end. Including a sign and units, that's fine. Yeah, that's clever. Include sign and units. Students, we realize that this whole section here, that there goes on to that section there. Just to be aware, it's really common for students to forget the symbol. Yeah, that symbol there, students usually forget because the calculator doesn't show it. Just be aware of it. I actually added another one to this worksheet after I posted that out to you guys. So I figured I'll run this one as well, because this one was a bit more challenging. What they've done is they've given you this horrible cycle, which looks disgusting, but in reality, it just doesn't matter. Yeah, what we're going to do is find the data that matches each step. So let's have a look at this one. I'm looking for carbon reacting with oxygen to form CO2. Right, step number 1, carbon to carbon. Nope. The next one, carbon to carbon. Nope. Carbon. Ooh, found it. Check this out. Carbon going to CO2. Check out everything else. Everything else, calcium chloride aqueous, stays the same. Water liquid stays the same. So the only thing that's happening in that process there is carbon turning into carbon dioxide. So I can add that value in now there. I can go minus 393. There's a 1 here, there's an invisible 1 here, there's an invisible 1 here. So I don't have to multiply it. That's awesome. Done that one. So orange is done. Let's tick that one off and get rid of all of these stuff. I'll actually highlight that as well. Next, so let's go for green. Let's go for this one. Hydrogen plus oxygen going to water. So I'm looking for hydrogen, found hydrogen. For hydrogen going to water. I like it. There's that arrow. I'm going to assume that everybody else stays the same. Stays the same. Stays the same. Stays the same. Amazing, because oxygen doesn't matter because it's still oxygen gas. It's making no difference. In reality, of course, we know that half the oxygen is being used up in that process, hence why it's changing. But that's nice. So we found the green change now, which is cool. Now I can apply that number. So in this equation, there's an invisible, there's a 1 there, there's a 1 here. I just apply that number straight in there, minus 285. Next, let's find the next one. Let's go for pink. Let's find this one. Calcium carbonate reacting with HCl. Find calcium carbonate. There's calcium carbonate. Right, and calcium carbonate forming HCl. There's that arrow. Right, apply that number. The numbers in front of the equations are all the same. That's cool. So I can now go pink. Come on, Mr. Duncan. There we go. So I've got minus 54. Oh, it didn't let me select it. I like selecting my colors. Give me pink. I want pink. Is that going to work? Oh, it's making me do that. Okay, so that becomes minus 54. I like it. There's a 1 here. There's a 1 here. So I don't need to change anything. That's awesome. Last bit of data. Right, the red one. I need the red one here. I'm assuming the red one's going to be this one. Let's just check. Calcium metal reacting with HCl to form calcium chloride. Yep, that's the one. Let's add my data. So that becomes minus 168. The numbers are all the same as well. There's a 1 here in front of the calcium, 1 there in front of the calcium. It's all good. No multipliers needed at all. Now I can do my big arrows. Most important arrows in any Hess cycle is going to be that this way here equals this way here. Let's create my cycle, create my equation. So this one here is with me. So delta HF equals, that one's with me. The red one is with me. So I've got plus brackets minus 168, close brackets. The green one is with me, plus brackets minus 285, close brackets. The orange one is with me, plus brackets minus 393, close brackets. And the pink one is against me, minus brackets minus 54. And I get my final answer of, on my calculator, plus brackets minus 168, close brackets, plus brackets minus 285, close brackets, plus brackets minus 393, close brackets minus 54. And I get an answer of minus 792 kilojoules per mole. And we're done. Whew, that was fun. I really enjoyed that. It was a lot of fun, that. I love the color coding. Color coding is awesome. You realize how useful it is in these particular scenarios, because it kind of helps understand where all the numbers are coming from. Yeah, it's really, really nice. And so, by the way, let's just chat, just curious. If I react calcium and hydrochloric acid, yeah, that's going to be very exothermic. Yeah, it seems very reasonable. Yeah, okay. Quite like that. Fun game. Right, guys, I'm going to end the lesson there. If you're curious, and I've got 5 minutes to go before my next lesson, I'm not really meant to. If you're curious, I was showing you the fact that you can do this entirely without cycles. Yeah, you can do this from a perspective of equations. So I'm just going to show you this side by side, just to, you know, what the wow factor in chemistry. Check this out. So the original equation was calcium reacting with HCl plus, and there's 2 of them, plus HCl plus carbon plus 1.5 oxygens goes to calcium carbonate plus 2 HCl's. Right, I'm going to build this purely from equations. I want calcium. Where do I find it in my data? There's only one equation that has calcium in it, and that's the red one. And the calcium is on the correct side of the equation. They're both on the left. That's great. So I'm just going to write calcium plus 2 HCl's goes to calcium chloride plus hydrogen gas. And the value there is minus 168. I can now tick him off in red. Tick and tick. Right, now it's also given me the 2 HCl's. That's awesome. Check that out. That's also given me him and him as well. The correct numbers. How boss is that? I'll take that one. Next, now I need carbon. Where do I find carbon? Yeah, where's the equation with carbon in it? There's my carbon equation. And it's on the correct side of the equation. So carbon, this is where I should have actually had everybody all line up, but I feel like I don't have an awful lot of space for this. So I really ought to. There's so much. Anyway, carbon plus oxygen goes to CO2. Right, and I've got one that's minus 393. Right, I can tick him off now. That's amazing. Right, now I'm going to ignore the oxygen because oxygens are appearing all over the place anyway. I now need calcium carbonate. Where do I find calcium carbonate? There's only one equation with calcium carbonate in it, and that's pink. And the calcium carbonate is on the wrong side of the equation. So I'm going to turn the entire equation around. Yeah, I'm going to write CO2 plus H2O plus calcium chloride goes to 2 HCl's and calcium carbonate. And there is my calcium carbonate. Now, because I flipped around the equation, I need to flip the enthalpy change as well. Right, next, so I've ticked off my calcium carbonate. Now, what can happen is, I need HCl's. Well, hang on a minute. That HCl there is going to cancel out with that HCl there. That carbon dioxide cancels with that carbon dioxide over there. Right, I've got hydrogen. I need to get rid of hydrogen. There is no hydrogen up here. I need to get rid of hydrogen. I need hydrogen on this side. Where do I find an equation with hydrogen in it? Green. So the green reaction gives me hydrogen on the correct side to get rid of it. How cool is that? 1.5 oxygens. So that's going to form H2O. And I'm going to get minus 285 for that. Now I can cancel out the hydrogens, which is awesome. Now, what else do I now need? Yeah, the calcium chlorides. Oh, look, calcium chloride here is on that side. It's on the right-hand side. But the calcium chloride over here is on the left-hand side. So they cancel out as well. So everything cancels. Where's my water? Oh, look, the water cancels out as well. That's awesome. Who's left? Not an awful lot left. I've got calcium left over. I've got, where's my HCl? I feel there should be HCl somewhere in this. Oh, have I missed? Oh, my HCl's disappeared. Guys. Oh, that's odd. Where's my HCl gone? Oh, hang on. Whoa. Have I written an equation wrong? Ooh, where's he? Oh, my carbon I've got. I've written an equation badly, and I've cancelled something that shouldn't have cancelled. No, I haven't, though. Oh, hang on a minute. Oh, whoa. Hang on. I'm an idiot. I'm an idiot. Guys. Oh, that's stupid. Guys, look. It's on the other side. Look. It's on the other side of this equation. It shouldn't even be there. Stupid thing. That's weird. That shouldn't even be there. They're just trying to freak me out. And they did. Oh, so they don't even matter. That's just irritating. Right, so now I have everybody. Let's identify everybody. Calcium. Don't need the HCl. Carbon. Oxygens. Oh, hang on a sec. I've got too much oxygen. Oh, hang on a sec. I've got too much oxygen. Was this meant to be? It's 1.5. I haven't balanced it properly. 1.5 oxygens. Sorry, look. It's over here. I didn't balance it properly. Look, guys. I didn't balance it properly. It's 1.5. So that makes sense because look, 1/2. I definitely have oxygens, right? So now that's ticked off. Now, do I have calcium carbonate? Calcium carbonate, I've got that there, and then the HCl's don't appear. Right, so all I now have to do is add those numbers together. Quite literally, bracket everybody, bracket them all, and then just put a plus in front of all of them and add them together. So plus brackets minus 168, close brackets, plus brackets minus 393, close brackets, plus 54, close brackets, plus brackets, plus 2, plus 285. Oh no, right. Type in the calculator, plus brackets minus 168, close brackets, plus brackets minus 393, close brackets, plus brackets, plus 54, close brackets, plus brackets minus 285, close brackets, and I get exactly the same number that I did over there. Oh, it can be done. It can be done. Wow, that was an entertaining lesson, wasn't it? I think his chat's off. That's correct. I did have my chat. Isn't it 105? Oh, have I made a mistake? I think so too. Oh no! Have I made a mistake? 105. Have I made a... Did I type it in wrong? Oh no. Minus brackets, plus brackets. This is where my calculator's causing me problems. 126, close brackets, minus brackets, minus 2, 3, 1, close brackets. 105. I got the calculator 105. Sorry. 105. 105. All right. Right. Guys. Oh, that's cool. It seems more complicated. That's cool, but it seems more. You'll have to be able to do it. Cyan, yeah, you have to be able to do that. Yeah, Edexcel will make you do it. Anyway, I will see you guys later. 24 minutes. Right, guys, I will post your homework of combustion and formation cycles on the chat. Sorry, on the classroom. I'll see you guys in the next lesson. See you later, guys.